Okay, it's a little bit after 1:30 Central Time, so we will get started. Welcome, everyone, and thank you for choosing to attend our talk on integrating Common Core math standards into Wolfram Alpha. My name is Anne-Marie Torreson, and I recently joined the Wolfram Alpha math content team as a math education specialist. And previously, I was teaching high school math and working on a master's degree in teaching secondary math. And so when I joined the Wolfram Alpha team, this project of the Common Core was already underway in the hands of the amazing Jeremy Stratton-Smith.
Thanks, Anne-Marie. I'm Jeremy Stratton-Smith. I'm a math content developer for Wolfram Alpha. I've been with the company for just under 2 years now, and was really excited to get this project moving about 9 months ago, I think. And I also have some teaching experience before starting at Wolfram. I was teaching for a year, so it was really great to get into this. Um, so today we are going to be talking through a little bit of background around what are the Common Core state standards for folks who might not be familiar with them, and then we're going to get into some of the details of how these have been integrated into Wolfram Alpha and how you all as end users can access and interact with them. And we'll wrap up with some future work and the continuing ongoing things that we're doing to flesh out our support of the Common Core standards.
So, as Jeremy mentioned, starting with a brief overview of what the Common Core state standards are. Well, the Common Core standards exist for both math and English language arts, and they're a set of topics for what is suggested to be taught from kindergarten through 12th grade in the United States. And the standards are posted online. You can just go to Google Common Core Math Standards and you'll see all of the standards. They were released in 2010, created by a collection of states, and then each state was given the option to adopt the Common Core standards. And as you can see, the Common Core standards were widely adopted as of now. 41 states and Washington, D.C., Guam, Northern Mariana Islands, and the U.S. Virgin Islands have chosen to adopt the math Common Core standards. So since they're so widely used already in the United States, we thought that the Common Core standards were a good starting place for us to start implementing kindergarten through 12th education in Wolfram Alpha. And then something that is distinct about the Common Core standards is their emphasis on mathematical rigor, which from an education standpoint means that the standards cover procedural, computational fluency, standard addition, subtraction algorithms, and so on. But equally, they also cover applications to physical world, real world scenarios, and also conceptual understandings of broad mathematical concepts. And so we can support each of these aspects and have them combine to really create that sense of rigor in Wolfram Alpha to support the Common Core standards. So we'll talk about how all of that works in a little bit, but first, Jamie's going to talk about the structure of the standards as they currently are in Wolfram Alpha.
Awesome. Thanks, Anne-Marie. So the Common Core, the folks who made the Common Core state standards actually made it really easy to begin interacting with them as in a computable form, in the data form, because they are all available as XML on the Common Core developers page, which is linked in our slides here. So it was really fairly straightforward for some of the more adept data folks in Wolfram Alpha to pull that in and get us initially set up with the standards, which is really great. And let us begin looking at how can we think about querying these standards and how are they all related to each other. As you can see here in our graphic, the standards are broken down in two primary ways. The first being grade level, where we have K through grade 8, and then high school. The high school is grade levels are all lumped together to allow high schools the opportunity to either do an integrated math approach where you cover all domains each year from 9th to 12th grade, or to do a more traditional approach, which would be Algebra 1, Geometry, Algebra 2, and so on in high school. as I've already mentioned, there are then also the content domains, which are a little bit more ragged. They don't span necessarily all of the grade levels. And even if they do, like geometry, they're broken up because the ideas and the content specifics are different between K through 8 and high school. And then some others, for example, looking at expressions, the ideas and what's being explored in those content standards changes. So in the green, right in the middle, we can see from K through grade 5, it's operations and algebraic thinking, going up to expressions and equations, and then to high school algebra. So this is great. This is an overview of sort of what the way that the standards are broken down. But when we get to looking at specifics of standards, some people might be familiar with this sort of this period separated, long looking standard ID, which I think is one of the things that can be intimidating about the Common Core. It's really not. This is just the systematic way that the Common Core that you can refer in the Common Core, you can refer to each individual standard. So we have the CCSS, that's the Common Core State Standards. Math, because there's also the English standards, so we differentiate from English. Content, because we're talking about specific content information. So knowing something about the distributive property or some sort of specifics. We're going to be looking at more of these. These are differentiated from the standards of math practice, which are a group of 8 sort of overarching fleshed out guidelines for how to do math that can be applied at any grade level and really should be integrated and highlighted throughout all of the K through 12 education system. So we're not talking about those right now, but they are accessible as well. So we have the content standards and then the grade level specified by a number, then an abbreviation for the content area, which are the little headers in the table that we saw above. And then the final pieces are just specifying within those standards, a small grouping. So we can look at an example here for this standard. And what this gives us is we get our standard name. We can see that the content area, we're talking about a measurement and data standard. And the description is measure the length of an object by selecting and using appropriate tools such as rulers, yardsticks, meter sticks, and measuring tape. So this is more of an application type standard because we're having to do something and making choices about what kind of tools to use. But this is an example of a standard, sort of a bite-size piece of knowledge to cover. So with that, I'm going to hand things over to Emery to look at some examples.
Great, thanks. So with the standards in place, we've got standards and we think about, well, what can Wolfram Alpha do? What results can we produce that are aligned with the standards that could help what a teacher or a student who's working on a specific standard? And so here we've thought about back to those 3 elements of mathematical rigor. The procedural fluency, conceptual understanding, and applications, they happen together and they combine to make a really rigorous and thorough math education. But certain standards kind of lend themselves to one or the other. For example, here we've got this standard ID, which we can search to find that it is a number and operations in base 10. It's MBT standard for 5th grade. And the description is to fluently multiply multi-digit whole numbers using the standard algorithm. So this is a pretty straightforward procedural fluency standard. It's asking us to use an algorithm to perform multiplication. So in Wolfram Alpha, you can search for a multiplication problem like 12 times 17, and we have these results. And in particular, when we have this step-by-step solution option, we can see that the standard algorithm is given here, at least for the United States. And so the Wolfram Alpha result supports the procedural fluency dictated by this standard. Okay, another example, given another standard. Let's look at this standard. This is a 1st grade numbers in base 10 standard. And as you can see, there's flexibility in how you can query the standards. You can just give descriptions of what each part of the ID means and get the standard. So another NBT numbers in base 10 standard. But this one, you can see, is a little less bite-sized. There's a little bit more to it. This is now about addition, adding within 100. And this standard asks us to use concrete models or drawings and strategies based on place value, properties of operations, and so on. So the phrasing of this standard is really also emphasizing the conceptual understanding, not just following an algorithm. So we go to Wolfram Alpha, we ask it to add two numbers within 100, like 24 plus 18, and here we get our result. And again, the step-by-step solution is available for the procedural fluency. And also, we have these visualizations, which are the concrete models or drawings that can represent the concept of addition. So we have the option of a number line, seeing addition on a number line. And then this manipulative illustration in particular is really great because it uses that place value understanding with the tens and the ones, and even addresses some of the specifics of the standard when we need to compose a 10 out of the 1 units. So here's another example of how Wolfram Alpha is aligned to a Common Core standard. Okay, and finally, for the last aspect of mathematical rigor, applications, Jeremy's going to show us an example in Wolfram Alpha Notebook Edition.
Great. So as I'm sharing my screen here, I just wanted to point out, somebody asked in the chat that some of these queries are not yet going to be working for you all, and that's totally fine. These are rolling out over the next few weeks. So some of these are going to be accessible. So yeah, so the content standards should be accessible within, at most, a month. It should be sooner than that, most likely. For those of you who were at the keynote talk last night, you've probably already seen an example of this, Wolfram Alpha Notebook Edition, or a Wolfram Alpha Mode notebook. This is an environment that really takes the best of both Wolfram Alpha with the natural language understanding and the ease of use, and the best of the notebook environment where you can build up computations over a series of, or you can build up understanding and larger tasks over a series of smaller computations. So for example, here we're going to look at a more application-based standard. This is an expressions and equations, and it says solve real-world and mathematical problems leading to 2 linear equations and 2 variables. There's more to this, just an example of what this is what we're going to primarily be looking at. So this is the kind of thing that in many classrooms would be covered by some sort of word problem, which can be difficult to handle. There's lots of ways to write word problems, and there's lots of ways to put in extra information and complicating factors, which make these difficult to sometimes parse or interact with in a computational way. But on our end, this is something that can be really easily and nicely handled here in the Wolfram Alpha Notebook Edition. So our problem: 2 sisters are in a competition to raise money for a school trip by selling candy. Latoya already has $50, but only makes $5 per sale. Jasmine, on the other hand, only has $25, but makes $10 per sale. So she's a better salesperson. When will they have raised the same amount of money, and how much will that be? This is a classic kind of intro linear equations word problem. One of the things that a student would be asked to do here is to be able to identify what are the key pieces of information that we can take out of this to build a model of that linear equation. And the 2 pieces for each of our sisters here are the initial value, the $50 in Latoya's case, and then the rate, $5 per sale, right? So taking those pieces of information, we can build it and say that a student doesn't necessarily know how to write that equation themselves. We can say, okay, give us an equation with this slope and this y-intercept, and Wolfram Alpha Notebook Edition very neatly gives us our y equals 5x plus 50, that standard y equals mx plus b equation. Similarly for Jasmine, we can pull out those same pieces of information. And then the key piece of this, which is how do we go about solving these now that we have these 2 equations, that's really great, but we can really easily say solve that and the one before to not only just build up our 2 equations, but also get our solution, which is after 5 sales, each sister will have $75, right? So answering how many, when will they raise the same amount of money, and how much will that be? Additionally, just in case you wanted to, just to highlight that we can also get our steps solution here for the procedural fluency part as well. So with that, I'm going to hand over to Anne-Marie in just a second, but in addition to being able to highlight these sorts of individual sample problems in Wolfram Alpha Notebook Edition, the example pages that Anne-Marie is going to talk more about are going to be immediately accessible here, right from within Wolfram Alpha Notebook Edition, so that teachers and students and parents can not only see individual standards, but also see our curated set of examples that go along with all of them. So with that, to talk more about this, I'm going to hand back over to Anne-Marie.
Thank you. Okay. So as Jeremy mentioned, you can see examples organized already for you in Wolfram Alpha Notebook Edition and also on the Wolfram Alpha website. So we've been curating and compiling examples that are aligned with each Common Core standard and putting them all in one place so that they're accessible and organized for whoever wants to use them, whether it's teachers, students, a family member helping a student learning from home this year. If they're looking on the Common Core Math, you can go to the mathematics example pages. So on the Wolfram Alpha website, you can browse examples and see examples, or they're actually already listed here by topic. So in the mathematics example pages, you already have lots of examples. So for example, if you needed to know how to type in an integral to compute it in Wolfram Alpha, there's an example for that. And what we are building and what should be available to everyone soon, this is just an internal version right now, is a section on the mathematics example pages for Common Core Math. And so this Common Core Math example page will be sorted both by grade level, all the grade levels, all of the Common Core content areas, and you can click here and explore between grade levels and content areas examples aligned with specific standards indicated by their standard IDs. So we're hoping this will be a really neat tool, make the Common Core standards and Wolfram Alpha more accessible to a wide variety of people since the Common Core standards are so widely used. And as we've been putting together these example pages with all these lots of examples aligned to all sorts of different standards, we've also seen some opportunities for improving our alignment. So here's an example of one of the things that we've done. We've noticed that we can tweak our features to work better with the Common Core standards. So considering this fourth grade fraction standard, this standard asks us to compare two fractions with different numerators and different denominators. There's some info about conceptual understanding in there, and then record the results of comparisons with the inequality symbols and justify the conclusions with visual fraction models. There's a lot there. We start with an example of comparing two fractions with different numerators and different denominators, like a query, which is greater, 7/8 or 3/4. And the pods that come, the results we see the answer, and this is excellent. We also have two concrete visual models, both a number line and these pie charts. Also, we found opportunities to improve the results. So one thing that we can do is add this arithmetic comparison pod to address that inequality notation that's mentioned in the standard. So we'll give our answer also with the inequality notation to both align with the Common Core standard and also make it clearer for any math student to see the relationship between the two fractions. And other places that we can develop the idea of visual models in particular, they're really used widely to support conceptual understanding, and there are lots of varieties. So pie charts are great. Tape diagrams like these shown here are also commonly used. So we're exploring different types of visual models that we can give as results to support conceptual understanding. And all of these changes, since we're starting by looking at educational standards, help us to develop with education in mind. So having our results really be useful for students who are learning math at every level.
Awesome. So as we've already seen, this is well underway and is going to be soon to be available to all of our end users, both in Wolfram Alpha on the web and via Wolfram Alpha Notebook Edition. In particular, there are some features in Wolfram Alpha Notebook Edition, which we're not going to show now for time reasons, but it allows for more interactivity, and as we've already seen, the sort of more dynamic use from the users, and also when I say dynamic interactivity, like in producing manipulates and not just a static visual model, but something that somebody might be able to interact with. So we're excited to be adding more of those and making use of the Wolfram function repository to package up some of the code for these visualizations and interactive models as well. For more info, you can attend these 3 talks about Wolfram Alpha Notebook Edition that are all on Friday to learn more about that, and hopefully dive into that if you're interested. We're also looking forward to, as Anne-Marie said, continuing to develop our Wolfram Alpha coverage of the specifics and the sort of the specific educationally minded aspects of the Common Core standards, in addition to furthering our integration with the Wolfram problem generator. This is a technology that's been around for a little while, and itself has some Common Core alignment, but we would really love to be able to tie that further into Wolfram Alpha and the results that you get on Wolfram Alpha from those pods. And finally, we're going to be adding, hopefully down the road, more support for other standards, both the Common Core English standards and other international and other sets of standards from around the world, which might use different algorithms or approach problems in different ways, which not only is it great to be able to cover those things and have support, but it also, I think, allows for students to really see that math isn't just done one way, that it's done in many ways around the world, and that just the way that your teacher is teaching things doesn't have to be the only way that you do math, which I think is a great thing. So with that, we will be wrapping up here. And again, I want to say thank you so much for attending our talk today, and particularly thanks to a number of developers on the Wolfram Alpha team who have helped make this project possible and get us to where we are here today. And at this point, we can take some questions, either in, I see there are a few which we can address in just a second in the chat, or if you want to raise your hand, we can also unmute you, I think. So I see we already addressed the question about other countries' curricula. Thanks for saying this is nice. And the next generation science standards, I think that is that's a great thing to consider, and it should be, yeah, probably bumped up our list, since that's pretty widely adopted throughout the US as well. So thanks for that suggestion. Yes, there was a great talk, which I think you can now go see the recording of this morning, on a math artifacts and history of mathematics project that was really great. Anne-Marie and I were talking about that before we got in here. Cool. Well, if there are, we can just hang out for a minute if people have questions, or if not, thanks everybody, and yeah, feel free to reach out to Anne-Marie or I. We'll put our contact information in the chat, so if anybody wants to reach out to us, or I think there's a meeting scheduling feature of Pathable, so you should be able to request a meeting with us if you want to talk more about this as well.